have to start from type 8, no? Type 8. Okay, under this type 8, type 8, okay, type 8 questions. There, we're supposed to discuss people this kind of integrands, cost product, cosine product, and sine product. This kind of integrand. We have a product of cosine sine or cos or sine sine. Right? This kind of integrands in this type we supposed to discuss. We haven't discussed the fifth type. So then all the things from the beginning I have discussed. Sometimes I didn't put that type 5. So therefore, we have to from the beginning number them correctly. All the types I have discussed. Okay. Then this should be type 7. Then type 5 I haven't put there. Only the number 5 missed. All the things I have done. Right. So then people, for example, now suppose this way, we are given this way, cos 2x into cos 4x dx. This way we are given the integrand. Even here we use the product formula. Right. Can you remember the product formula? 2 sin A cos B. You know people how to write this? Sin A plus B plus sin A minus B. 2 cos A sin B. These people minus here, no? Sin A plus B minus sin A minus B. Next one, to cos A cos B. In trigonometry, under product formula, we learn this. To cos A cos B is people what? Cos A plus B plus cos A minus B. Next one, to sin A sin B. What are these people? Cos A minus B minus cos A plus B. What we do is this product, we multiply by 2 and divide by 2 this way. Okay. When you take this 2x as A, 4x as B. Then for this one, you can apply this formula, 2 cos A cos B. Okay. Then you can write it like this, half integration. This one you can write cos A plus B, 2x and 4x, 6x, no? Plus cos A minus B, 2x minus 4x minus 2x, no? Cos minus 2x. But you know people, cos minus theta mean without this minus sign you can write this. Cos minus 2x is equal to cos 2x. The reason for this is cos minus theta is equal to cos theta. Without this minus sign, in the case of this ratio cos, we can write it. So using that, I can write this as cos 2x. Cos 6x plus cos 2x and dx. Now you can integrate this and this separately. So then we get half cos 6x. Its integral is sin 6x by 6. Sine 2x by 2 and plus c. C is any constant. C is any constant. This is how we take that answer. Right now? Okay. We'll come another one more. This one. This is sine 4x cos 2x sine 6x dx. Sine 4x cos 2x sine 6x dx. Right. Try to get this answer, people. Right now, people, we write this way. This sine 4x and cos 2x we take together and multiply by 2 and divide by 2. The sine 6x we keep aside like this. Now, here you can apply for this to sine A cos B. This one, sine A plus B at this 6x plus sine A minus B, 2x. And here sine 6x dx. Now what we do, people, this and this we multiply. Okay, now people, when you multiply by this, This is now sine 6x and again sine 6x and plus sine 2x sine 6x dx. We get like this. Okay. Now what we do is, again we multiply this by 2 and divide by 2. This also multiplied by 2, divide by 2. That dividing by 2 we take before this. Then with this 2 it will be 1 by 4. Right? Integration. This is now 2 sine 6x sine 6x. Right? And this is now 2 sine 2x sine 6x. Dx. Okay. Now again you can apply 2 sine A sine B. This here. And here 2 sine A sine B. Okay. Then we get 2 sine A sine B is people cos A minus B. Right? Cos A minus B. A and B both being the same. Okay. Then we get 6x minus 6x is 0. Minus cos A plus B, 12x. And here also cos A minus B, 2x minus 6x minus 4x. Cos minus 4x is cos 4x. Minus cos A plus B, 8x. Right? You know, people, cos 0 is 1. This is 1. This is 1. Understood? You know? Then you can integrate every term here. Right? Now take the answer, people. I write that here. 1 upon 4. Cos 0 is 1. Right. Integral of 1 is x, no? Cos 12x. It is sine 12x by 12. Cos 4x. Sine 4x by 4. Cos 8x. Sine 8x by 8. Plus k. K is any constant. K is any constant. This way you can take this answer. Right now? Okay. People, today I put this tutorial and then you can work out questions in it. I will come to the next type. Next type is therefore type 9, no? Type 9. Type 9 people. Other type 9 people we suppose discuss this kind of integrand, sine to the power mx into cos to the power nx, cos to the power nx dx, this type. Okay. Right now, sine cos product we have with the powers. Both this sine and cos have powers. The method is this. If this power of this sine is odd positive integer, that means this m is odd positive integer, we use m is odd positive integer. This m is the power of sine. If the power of this sine is odd positive integer, then the substitution we use t equals cos x. Right? If this n odd positive integer, that means the power of n, power of cos x is odd positive integer. People, substitution is t equals sin x. Right? T equals sin x. Okay. If both m and n odd positive integers, people, you can apply any substitution t equals cos x or t equals sin x. Right? Okay. If both are even positive integers, then we'll discuss the question. Thereby, we can come to the end of this part also. Right. Write down type 9, this one. Right. Right. Next one, people. If both m and n are odd positive integers, put t equals sin x or t equals cos x. Substitution, right? Thereby, you can do this. Okay, we'll take one. First one is sin squared x cos x dx. Here the power of cos is 1, odd positive integer. Then substitution is t equals sin x. You know, when we are using a substitution, how to integrate. First, differentiate that. Okay, right. Start that, people. Right now, people, here the substitution t equals sin x. You know, whenever we use a substitution, we have to differentiate that substitution. This way we get. Then use the first multiplication this way. Then we have dt equals cos x times dx. Okay. Right. Now, we take this one. Question is sin squared x cos x dx, no? Right. Then we can write Sine squared x. People, sine x only we put t, then this is t squared. Cos x dx. Cos x dx is dt. Now t squared when we integrate with respect to t, it is t3 by 3. People, but t is what? Sine x. Then we get sine cube x by 3 plus c. What is c? C is any constant. That way we can take this answer. Okay. We'll take another one more. Sin x times cos cube x. Both are odd positive integers. Next one. Sin x times cos cube x. This power is 1, this power is 3. Both powers of sin and cos odd positive integers. Then in this case, you can use either t equals sin x or t equals cos x. Whichever you use, you can get the answer, right? I will use t equals cos x. Then dt by dx. Cos x derivative is minus sin x. Then we get dt equals minus sin x dx. Then we get integral of sin x cos cube x dx. Right, people. This cos cube x I can write as t cube sin x dx. Sin x dx is minus dt. This is minus dt, right? T cube into minus dt. Take minus sign out. T cube dt. Then this is t4 by 4. But t is cos x. Then we can put that here. The answer is going to be minus cos to the power 4x by 4 plus k. K is any constant. That's how we take. Right now. We'll see people when both are even positive integers. Next one, like this. Sin squared x cos squared x dx. This way. Then how to take the answer? Yeah, you can do it like this. This one, next question, people. I multiply this by 4 and divide by 4. Sin squared x into cos squared x dx. Then you can write, people, this as the perfect square of 2 sin x cos x. This one you can write as the perfect square of 2 sin x cos x. But you know what is this? This is sin 2x. Then you can write this one as sin 2x perfect square. That means sin square 2x dx. Okay. Now the sin square 2x we can write, people, by using cos 2a formula. You know there are 3 formulae for cos 2a. You know, among them one is cos 2a is 1 minus 2 sin squared a. Once the subject here sin squared a, it is 1 minus, bring this side, this to this side, 1 minus cos 2a divided by 2. Here if we have the angle A, 2a is on the right hand side. Then people, if we have here for this a 2x, its double should be here. Then sin square 2x we can write as 1 minus cos 4x divided by 2. Therefore we can write this, right? We can write this 1 upon 4. It is now 1 minus cos 4x divided by 2 dx. This 2 and this 4 we can multiply, we get 1 upon 8. 1 upon 8, 1 minus cos 4x dx. Now you have to integrate. Integral of 1 with respect to x is x. Cos 4x, it is sin 4x by 4 plus k. K is any constant. K is any constant. This is how we take that answer. Right now? Right, people, now that's how we work out such question. Okay. Then we'll move to next type. Type what, people, 9 no 10? Type 9, no? Next one, type 9. And this type 9, people, we suppose discuss this kind of a plus b cos x dx, a plus b sin x dx, or this a plus b cos x plus c sin x, this form dx, right? Right now here the integrand contains sine and cos terms with powers 1 only at its denominator. Only at its denominator. In this type, the integrand contains sine cos terms with powers 1 only at the denominator. Right? In this case, people, if you find this way integrand having denominator sine terms or cos terms or both the sines and cos with the powers 1. People, in this case, right, we use a substitution. The substitution t equals tan x by 2. T equals tan x by 2. That is substitution. We know when t equals tan x by 2 under trigonometry, people, can you remember we wrote when t equals tan x by 2, we wrote sin x. How, people? How did we write this sin x when t equals tan x by 2? It is 2t divided by 1 plus t squared. Cos x 1 minus t squared divided by 1 plus t squared. Can you remember this? In trigonometry, we discussed this. Okay? Correct, no? So you know how to derive them. This sin x we can write 2 sin x by 2 into cos x by 2, no? The right hand side denominator here we have 1. This one we write how, people? We write it as cos squared x by 2 plus sin squared x by 2. Right? Now we divide both the numerator and denominator by cos squared x by 2. When you divide this numerator by cos squared x by 2, 1 cos x by 2 we can cancel down. The other one with this sign we get tan x by 2. 2 tan x by 2. Tan x by 2 is t, no? Therefore 2t coming. Here 1 plus tan squared x by 2. It is t squared. This one coming. Like that you can write cos x. How to write cos x, people? Cos squared x by 2 minus sin squared x by 2. Dividing that by 1 means same way, people, you can take this one too. Okay? Right, let's see how to take this. Okay, we have write this when t equals tan x by 2, sin x this, cos x this. This is a not. This we have done in the trigonometry part. Right. Right, first one, people, example we'll take. Integration 1 upon 1 plus cos x dx. Right. First take down this notes. Substitution is this. This one, when t equals tan x by 2, sin x is 2t upon 1 plus t squared. Cos x is 1 minus t squared upon 1 plus t squared. Right. Then the substitution for this is what, people? Substitution is t equals tan x by 2. We have to differentiate this substitution with respect to x. We get dt upon dx. Tan x by 2, when you differentiate, what do you get, people? 6 square x by 2 multiplied by the root of x by 2 is half. But you can write 6 square x by 2 as 1 plus tan square x by 2 into half. But tan x by 2 is t. Tan x by 2 is t. dt upon dx is equal to 1 plus t squared by 2. Because tan x by 2 is t, no? Then you can subject this dx. Bring this here, this, right? Therefore, dx is equal to 2 times dt divided by 1 plus t squared. Okay? And now we start from here. Now, this one, 1 over 1 plus cos x dx. 1 upon 1 plus cos x. Cos x means, people, 1 minus t squared divided by 1 plus t squared. Dx is 2 dt. Yeah, this dx. 2 dt divided by 1 plus t squared. Right. Now, by this 1 plus t squared, we multiply this and this both. Then the numerator we have 2 dt. Also use this to multiply this and this both. 1 into this is 1 plus t squared. And when you multiply this and this term, this 2 will cancel off, giving 1 minus t squared. This 2 you can cancel down. Then what we get is 2 divided by 2 dt. This is 1. Integral of 1 is, people, t, no? With respect to t, no? This time we integrate t. But what is t? T is tan x by 2. Tan x by 2 plus c. C is any constant. T is any constant. C is any constant. Right. Take this one. Next, ask the next question. 1 upon sin x plus cos x and 2t squared plus 1 dx. Right. Take this, people. Here also we have to apply what? The substitution t equals tan x by 2. T equals tan x by 2. Right. Take that, people. Okay, let's see how to do this. Right. Now, here also we have to apply the substitution t equals tan x by 2. After differentiating that, when you subject dx, we get dx as 2 dt divided by 1 plus t squared. I have in the earlier question the process of obtaining this dx, so then I am not going to do that again. Right. Now, right, I take this now. When I take it, one upon sin x plus cos x plus 1 dx, no? Right. 1 over, when t equals tan x by 2, sin x mean 2t divided by 1 plus t squared, cos x 1 minus t squared divided by 1 plus t squared plus 1. And this dx is 2 dt divided by 1 plus t squared. Now I can multiply by this 1 plus t squared all these three terms, right? This 2 I can take out because it's a constant. Once I take that 2 out, we get dt here. Multiply this and this 2 will cancel off, we get 2t. This and this 1 minus t squared. This and this we get 1 plus t squared. This and this we can cancel down. Okay. Now here this one and this one make 2. 2t plus 2. We can take this 2 out and can be cancelled on with this way. Here now we get 1. Then what we get is 1 over t plus 1 or 1 plus t. Both are the same, no? dt. People, what is the integral of this? These are the type. This, no? Integration 1 upon ax plus b dx. Linear function is at the denominator. What is the answer of this? ln modulus ax plus b divided by x coefficient a. Like that here. What is this? ln modulus t plus 1. T is tan x by 2. Plus 1 plus c. C is any constant. C is any constant. Right now? Okay. But people will take another one more. And then we can come to the next type. Next one, this people. Dx upon 1 minus sin x plus cos x. This way. Right. Here also we apply t equals tan x by 2 substitution. Right? Yeah. Take this, people. Right. We'll come to that now. Okay, now I'm directly substituting here. Right. This dx, you know, 2 dt divided by 1 plus t squared. 1 minus sin x means 2 divided by 1 plus t squared, and cos x 1 minus t squared divided by 1 plus t squared. multiply by this. We get 1 plus t squared here, minus 2t, 1 minus t squared. Plus 1 minus t squared, no? This and this you can cancel down. 2 can be taken out, dt upon 2 minus 2t. This 2 you can cancel down. 1 over 1 minus t dt. What are the answer, people, here? L in modulus 1 minus t divided by coefficient of t, it's minus 1 no, here. And now t is tan x by 2. Then we get what? Minus L in modulus 1 minus tan x by 2 plus c is any constant, right? That's how we take. People, some cases this denominator may contain quadratic expression. Then numerator 1, denominator quadratic. That occasion we have to go to the very first method we discussed starting very beginning of the start of this integration, 1 over quadratic function. So we have to factorize. If it is factorable, go through the partial fractions. Otherwise, complete the square. If the sum of two squares come in, after completing the square, through tan inverse. If it is perfect square, taking that to numerator, you can integrate. Okay, right. Now we'll move to the next type. What is that type, people? Type 9. No, type 9. Right. Take next one as type 9. Type 9 or 10. Right. Now, under this type 9, people, we supposed to discuss this type of integrands, type 10, no? Right. 1 upon a plus b cos squared x dx. Or 1 upon a plus b sin squared x dx. Or this way, 1 upon a cos squared x plus b sin squared x dx. Or this way, people, a plus b cos squared x plus c sin squared x dx. Here the integrand contains square terms of cos and sine. Square terms of cos and sine. Right? Write down type 10. This type of integrands we supposed to consider under this type 10. When we evaluate the integral for this kind of questions, people, the method is this. The method is this, people. The numerator and denominator, both we divide by cos squared x. Thereafter, we use a substitution t equals tan x. Understand? That's the method. Right? Right. First, write down this and then we'll write one sentence. Write down like this. Divide the numerator and the denominator. Divide the numerator and the denominator. Divide the numerator and the denominator of the integrand by cos squared x and use the substitution t equals tan x, not tan x by 2. T equals tan x. T equals tan x. We divide both the numerator and denominator of the integrand by cos squared x. Then we use the substitution t equals tan x. T equals tan x. Right? Yeah. Shall we take one question, people? Take this 1 upon cos squared x minus 2 sin squared x dx. Is the first one. Right. Take this, people. First divide both the numerator and denominator by cos squared x, and then for the new one put the substitution t equals tan x. Right. You have to first divide both the numerator and denominator by cos squared x. Right. Now when we divide this by cos squared x, numerator we have 1, no? This one we should divide by cos squared x. And this both we have divided by cos squared x. Here dx. 1 of cos squared x is 6 squared x. This is 1 minus 2 tan squared x dx. Now for this only we use a substitution t equals tan x. Now the substitution t equals tan x. What do you get there? Dt by dx equals tan x derivative is 6 squared x. Then use the cross multiplication by this dx. We get 6 squared x dx. Now come to this. Now this one we can write integral of 6 squared x dx divided by 1 minus 2 tan squared x. Right now, this 6 squared x dx is dt divided by 1 minus 2 tan squared x. Tan x is t, 2t squared. Right. Now take this, people, minus 2 out. That will be coming out as minus half. Once you take this minus 2 out, this will be t squared minus. This is now, people, what, half, no? Dt, this way we get. You take from the denominator minus 2 out, that one should be divided by minus 2. Then can somebody tell me the way of integrating this? Yeah. Now this part we take separately. Okay. This 1 upon t squared minus 1/2. This one I am going to factorize. It is t minus 1 over root 2 into t plus 1 over root 2. Okay. I can write this 1/2 as 1 upon root 2 perfect square. Here, therefore, we have difference of 2 squares. Then the denominator is factorable. When it is factorable, people, what is the method? Partial fractions. Now find partial fractions for this. Thereafter, we can integrate this. Then for the t, we substitute tan x. Right. Take people partial fractions. One upon it's a upon this way. Find this a and b. Use a shortcut. What a shortcut, people? When you find this a, come to denominator, equate that denominator to 0, find t. T is 1 over root 2. The same factor we close in the left hand side. Substitute that t we got where here for this t 1 over root 2. 1 plus 1, 2 over root 2. Right? 2 over root 2 means root 2 here. Then we get 1 over root 2 as what is a. A is 1 over root 2. And come to this t plus 1 over root 2. When we equate to 0, t equals minus 1 over root 2. Close that from here. Minus 1 over root 2. Minus 1 is minus 2 divided by root 2 is minus root 2. 1 over minus root 2. That means b is minus 1 over root 2. Now we know both a and b. Then we can evaluate this. Okay, I'll take this as star, people, right? This one I'm going to take as star. Right. So then we can write 1 upon t squared minus half dt is therefore this, no, just this, it is this now, right? A 1 over root 2 1 upon t minus 1 over root 2. B minus 1 over root 2 upon t plus 1 over root 2. Yeah, differentiate, integrate. What are the answer of these people? Ln, no? Right. 1 upon root 2 ln modulus t minus 1 upon root 2 minus 1 over root 2 ln modulus t plus 1 over root 2. This 1 over root 2 here and here you can take out. Ln difference we can write as a fraction, no? 1 over root 2 L in this divided by this. You see, we can write. But t is tan x, right? Therefore, we can now write 1 over root 2 L in tan x minus 1 over root 2 divided by tan x plus 1 over root 2. Now, people, this is the answer, right? Not this, by star, now we take the answer. Now, by star. Now, by star. Right. What is the left hand side? Left hand side is the people given what? Integrand. So we obtain this by using division by cos squared x. No? So then the given question is, we can write now by star. The given question was, people, 1 upon cos squared x minus 2 sin squared x. No? This was the question given. Its answer only now given by this star. It is minus half integral that one, people, now this answer. 1 over root 2, that means 2 root 2 here. L in modulus tan x minus 1 over root 2 divided by tan x plus 1 over root 2 plus c. C is any constant. This is how we take the final answer. Okay, no? Yeah. Right, people, shall we take another one more question from this kind? It is this. Dx upon 2 cos squared x plus sin x cos x. Right. Here also divide both the numerator and denominator by people cos squared x and apply the substitution t equals tan x. Right. Take this answer. Right. Now, when you divide this numerator and denominator by cos squared x, here we have dx means 1 dx. No, that dx I write here. This 1 we divide by cos squared x, the numerator 1, and this both we divide by cos squared x. Then we get 2 cos squared x divided by cos squared x plus sin x cos x divided by cos squared x. Okay, these two you can cancel down. 1 cos x cancel down with this. Here 1 upon cos squared x is, people, sec squared x dx divided by this is 2 plus sin x by cos x is, people, tan x. Okay. Now we use a substitution. T equals tan x. Whenever we use a substitution, you know we have to differentiate that substitution, right? dt upon dx is x squared x. dt equals x squared x dx. Then we can go to this. X squared x dx divided by 2 plus tan x is equal to x squared x dx means people dt divided by 1 plus tan x is t, 2 plus t. Then what is the integral of this? ln modulus t plus 2. But t is what? Tan x. Tan x plus 2 plus k. K is any constant. K is any constant, right? Yeah. Right now, that's that type. Right, people, now we'll come to the next type. Type number 11, right? Type number 11, right? Type 11. Type 11. Under this type, people, we're supposed to discuss both the numerator and denominator. We have sine cos terms. This is. Both this numerator and denominator, we have sine cos terms. Sine cos terms. Right? This is a type 11. Under type number 11, we're supposed to discuss this type of integrands. Both the numerator and denominator containing sine cos terms. Right? In the next case, we consider a constant also possible at the numerator and denominator of this integrand. We come to that under number 12. People, in this case, the way of evaluating this integral is we write one expression like this. We write numerator, right? Numerator is equal to lambda times denominator plus d over dx, mu times d over dx, derivative of denominator. What we call this? D over dx denominator. That means this denominator we differentiate with respect to x. That way we write and we find lambda and mu. All right, first we'll take down this. Right, this is the type. Lambda times denominator plus mu times d upon dx, that means the derivative of the denominator. This way we write. And we find this lambda and mu. Right. We find this lambda and mu. Right, now we'll come to one question here, people. 3 cos x plus 2 sin x divided by 4 sin x plus 5 cos x. 4 sin x plus 5 cos x dx. This is the question. Right. Then first we write this one. Right. Numerator is this 3 cos x plus 2 sin x is equal to lambda times denominator 4 sin x plus 5 cos x plus mu times derivative of denominator. When you differentiate this, 4 sin x derivative is what? 4 cos x. 5 cos x derivative is minus 5 sin x. Cos x derivative is minus no, right. Then we equate the coefficients of sin and cos on both sides, right? I can write equating the coefficients of sin x and cos x. First on sin x, coefficients. What do you get here? Right hand side 4 lambda minus 5 mu. 4 lambda minus 5 mu is equal to 2. Cos x. We equate the coefficients of cos x on both sides. Right hand side here 5 lambda plus 4 mu. Left hand side is 3. Number 2. First, people, by solving these two simultaneous equations, find lambda and mu. Then we substitute them here for lambda and mu. Right. How take this now? First equation, we multiply by 4. Then we get minus 20. Second equation, we multiply by 5. And we add them up. Here minus 20 coming, here plus 20 coming. We cancel off. Then here, this is multiplied by 4 no 16, here 5, 25. 25 plus 16 means 41. 41 lambda. Right hand side of number 1, when we multiply by 4, we get 8 there. Number 2, right hand side, 15, no? Then lambda comes as 23 divided by 41. And second, to find this mu, what we do is, people, first one we multiply by 5, second we multiply by 4, and we subtract. When you multiply first one by 5, we get 20 lambda, this by 4, 20 lambda. When you subtract, they will cancel off. Then 5 mu into 5 is minus 25 mu minus, this is minus 16 mu. Right hand side of number 1 is multiplied by 5, we get 10 minus 12. Then here minus 41, mu come in, minus 2, then mu is 2 divided by 41. Then we found, people, both this lambda and mu. Now we rewrite this one, substituting for lambda and mu. Substituting for lambda and mu, we rewrite this. Right? Okay. Then we have lambda 23 by 41 mu 2 divided by 41. Right? Now, if I write this one, substitute for lambda and mu, 3 cos x plus 2 sin x equal to lambda 23 divided by 41 4 sin x plus 5 cos x. And mu. Mu is 2 by 41. 4 cos x minus 5 sin x. Right. What I did, I substituted for this lambda and mu. We are here and here. Okay, now both sides of this, I am going to divide by 4 sin x plus 5 cos x. This way. Why? Once you divide like that, we can form in the left hand side the integrand given in the question, right? Yeah. 3 cos x plus 2 sin x divided by 4 sin x plus 5 cos x. Then right hand side, when you divide, we get 23 by 41, 2 by 41 times 4 cos x minus 5 sin x should be divided by 4 sin x plus 5 cos x. Now, people, you can see, what is this? This is the given integrand. This is the given integrand. Now we integrate both sides of this. Then what do you get? 3 cos x plus 2 sin x divided by 4 sin x plus 5 cos x dx equals, we have to integrate this. Take that out. This is a common constant, no? 1 dx plus 2 divided by 41 integral 4 cos x minus 5 sin x divided by 4 sin x plus 5 cos x dx. This way. Here, what is the integral of this one? It is x. Now, how to integrate this, people? Here, you know, when we differentiate this denominator, its derivative available at the numerator. See here, we differentiate 4 sin x. What's the answer? 4 cos x. When you differentiate 5 cos x, it is minus 5 sin x. Derivative of this denominator available at the numerator. That is of the form this, no? We have a denominator fx, numerator f dash x. This way. Derivative of this denominator available at the numerator. What is the answer? It is ln modulus denominator. Ln denominator. So then this is x. plus 2 upon 41 ln modulus the denominator 4 sin x plus 5 cos x plus c. C is any constant. This is any constant. This is how we take the answer. Understand, people? Right. I will take people another one more. It is this. Sin x divided by sin x minus cos x dx. All right, take this, people. Take this. People. Okay. So then here also we can write numerator sin x is equals lambda times denominator sin x minus cos x plus mu times derivative of the denominator. Sin x, when we differentiate, we get cos x. Cos x, when we differentiate, we get minus sin x. With this minus sign, we get plus. Then you get the coefficients of sin x on both sides. Here lambda, over there mu. Lambda plus mu is left hand side 1. Cos x, when we equate, people, here we get minus lambda, over there plus mu, but people left hand side we don't have cos x. That means the coefficient of cos x in left hand side is 0. This is therefore lambda equals mu. Therefore lambda plus mu equals 1 and lambda mu being equal, therefore lambda equals mu equals half. Lambda equals mu equals half, right? Right, now we can substitute that lambda mu value here. Now you can write sin x equals half times sin x minus cos x plus half times cos x plus sin x. Now we divide both sides by sin x minus cos x. Then we get to the left hand side sin x divided by sin x minus cos x, and here half sin x minus cos x, when you divide by the same thing we get 1 there, plus half cos x plus sin x divided by sin x minus cos x. Now we integrate these people. Right, and here we integrate 1, no? And here we integrate this. Then here integral of 1 is x, then half x plus half, this is ln modulus this denominator, sin x minus cos x plus c. C is any constant. C is any constant. Right. Well, actually we have another 1, 2, 3 forms. Then the basic types of will be over. Right. After that, we have integration by using the partial fractions, and we come to the definite integration. Okay. Right, so therefore, today I suppose to finish this lesson here. Right? Any question, people?